Alright, this is lesson 72, graphing and identifying exponential growth and decay. So today we're going to talk about graphing exponential functions. So there's two kinds, exponential growth and exponential decay. I'll explain how to read that. We use exponential growth and decay in a lot of things. Exponential growth, again, could be used in money. So some people take, they're like, I saved all this money, I want to invest it so it grows over time so that when I'm this old, I have enough money. So you might say, I'm going to do that now because I want to buy a house when I'm 30, okay? So you might say, I'm going to take my savings, maybe your parents have saved up money for you and you have like $5,000 bucks. And they're like, okay, you can do what you want. You can either spend it now or you can save it. So some people save it, and so they build interest. They might put it in the bank, and so year after year their interest grows. And their interest grows, and year after year it compounds, and it exponentially grows. And some people are really good at it, and they'll actually invest money into the stock market. They might get a mutual fund, or they know how to trade, and so they get capital gains. And after year, they make their 5,000 grow into the, tens of thousands or hundreds of thousands, and they're really good at it. And so that's something that you might want to do, and that's the concept we're learning today. And that could be any of you. You could even trade the stock market even as a teenager. Okay, so here are the steps for today. Make a table of values, solve the y for each x, graph the ordered pairs, and identify if exponential growth or decay. Okay, so let me show you how to do numbers 1 and 2, and then we will work on a couple together. Okay, number 1, y is equal to 5 times 2 to the x power. Okay, so whenever you want to graph something, whenever you're in doubt, make a table of values. So that means making a XY table. And when I do that, I always pick the same ingredients, -2, -1, 0, 1, and 2. So whenever you see X and Y, that means we're putting inputs in to get an output, just like I would put ingredients to make cookies into a machine. I should get cookies out of the other end. So I'm going to put these numbers in to whenever I see an X into my equation. So when I put -2 here, 2 to the -2 is 1/4. 1/4 times 5 is 5/4. Okay, next one, -1. 2 to the -1 is 1/2. 1/2 times 5 is 5/2. 0. 2 to the 0 is 1. 1 times 5 is 5. 1. 2 to the 1 is 2. 2 times 5 is 10. 2. 2 squared is 4. 4 times 5 is 20. Okay? And I could keep going. I could do 3 if I wanted to. 2 to the 3rd is 8. 8 times 5 is 40, right? But 40 is already off my graph, so I don't need to worry about that. And I could go the opposite way too, -3. If I were to put -3, let's say I put it up here. 2 to the -3rd is 1/8. 5 times 8 is 5/8. Okay, so I'm getting smaller and smaller fractions. So it could keep going any way you want, but we just want to graph, take a few and see what the pattern, what's happening. Now I'm going to graph these. I might as well just put -3 and 5/8 in there too while I'm at it, which is about there. We had -2 and 5/4, which is like 1 1/4 right here. We've got -1 and 5/2. And then we got 0.5. And then we got 1/10. And then 2/20, right? 3/40 is too big. But you could see there's a progression here, right? I could see that it's going up really high and then it comes down and curves really quickly down here. So if I were to graph this, it actually would look something like this. I'm going to put little arrows at the end, and it will look like that. All right. So this graph is growing quickly. It's exponentially growing. So the way I need to know, the last step I need to ask myself, I have to identify, is it a growth or decay? And the way you do that is you read the graph left to right. Okay, from left to right, what do you see? Is it growing or is it decaying? What do you think? It's growing. So this is called exponential growth. Okay. Okay, so that's number 1. Okay, again, what did I do? I made an XY table, picked some inputs, ingredients. I usually pick -2 to +2. And I actually kept going in each direction to see what the pattern was, just to make sure I was doing it correctly. And to predict what my graph would do. Then I take each ordered pair and I graph the ordered pairs, and I did that. And then I identified it as exponential growth by reading it from left to right. What's the graph doing from left to right? It's growing, right? Number 2, watch me do number 2 now. 5 times 1/2 to the x power. Again, I'm going to start with an XY table. Okay. I'm going to pick ingredients, -2, -1, 0, 1, and 2. Let's just start with those, see what happens. Okay. So -2, 1/2 to the -2 power is 4. 4 times 5 is 20. -1, 1/2 to the -1 power, we just get the reciprocal, is 2. 2 times 5 is 10. 0. Anything to the 0 power is 1. 1 times 5 is 5. 1 times 1 to the 1, or 1/2 to the 1 is 1/2 times 5 is 5/2. 2, 1/2 to the second power is 1/4 times 5 is 5/4. 3, I could keep going here. I'm noticing there's a pattern here, right? I know this is 5 over 1, this is 5 over 2, 5 over 4. This one should be 5 over 8, right? And I could keep predicting that this one would be 5 over 16, right? I'm noticing that these are doubling every time. You see the denominators doubling. Okay, just like if I go the opposite way, if I put -3, what do you think would happen if I put -3? What would be my number up here?
40.
40, right? Do y'all see that pattern that's happening?
Yeah.
Okay, it's doubling as we go up, and it's the denominator is doubling as we go down. Okay, so now I have a good selection of points here. These are all my ordered pairs. -340 is way too big for this graph, but I could put -220, -110, 0.5, 1 and 5/2, 2 1/4, 5/8, and I could predict that this is what my graph's doing, right? It's actually getting smaller and smaller, but it's never really crossing the x-axis here, right? So now I'm going to take my, draw this carefully. Hopefully it turns out okay. It's hard to do it on my iPad. Draw an arrow at the end here. Okay, drawing an arrow at the end here too. And you can see that this graph is turning quickly at the end. It will never really cross the x-axis. We'll talk about that next week, what's happening there. But this is how you graph, okay? Last step, we want to ask ourselves, reading from left to right, is this graph exponentially growing or exponentially decaying? What do you think? Decay. So then we would say this is exponential decay. Okay? Okay. So, and by the way, like this is an example in biology. You ever hear of half-life? Raise your hand if you've heard of half-life, right? They could do carbon dating on a fossil, and they'll say, hey, there's a half-life to the carbon. So there's an actual model that they use that looks just like this. They'll say after so many thousands of years, you'll have this certain half-life. The amount of carbon in this fossil will be half, right? And they could predict or get a good idea of how old something is based on carbon dating. Okay? So what I'd like you to do is just turn to your neighbor. I'm not going to tell who talks about what, but discuss how would you... Okay, let's do one more. I'm going to do one hard one with you. So number 4. Just do number 4, not number 3. Number 3 is cupcakes. Okay. Okay, what are you noticing about number 4 in regards to the exponent? Subtract by 2, right? If I have an exponent that is negative, what's going to happen to it? What are we noticing? It's going to be a fraction, right? And we know that there's going to be more and more fractions. So we always want to get our exponent to be 0. Why do I want my exponent to be 0? What? It's equal to 1, right? If I have a 0 as an exponent, it's equal to 1. So how do I make my exponent 0? Set x equal to 2, right? So that should be kind of my middle ground on my table. Does that make sense? So I don't really want to pick negative 2 because negative 2 minus 2 is negative 4. And then all of a sudden I got a little exponent, right? So let's pick 2 as the middle ground. So I'm going to make an xy table now. And instead of picking negative 2 as my starting point, let's put 2 in the middle, right? And let's pick two bigger numbers, 3 and 4. And let's pick two smaller numbers, 1 and 0, right? Because I know if I put 2 in here, 2 minus 2 is 0, right? 2 to the 0 power is 1. 1 times 3 is 3. 3 plus 2 is 5, right? That was easy, right? Let's pick 1. 1 minus 2 is negative 1. 2 to the negative 1 is 1 half. 1 half times 3 is 3 halves. Right? 3 halves is like 1 and a half. 1 and a half plus 2 is 3 and a half. Okay? I could do that as a side problem. Anyone want me to do that as a side problem for them? Raise your hand. Okay, how did I do that? Got 3 times 2 to the x is 1 minus 2 plus 2. Okay? 1 minus 2 is negative 1, right? 2 to the negative 1 is 1 half. Would you all agree with that statement? Bring the rest down. We got 3 plus 2. PEMDAS, right? We have to multiply before we add. This is like saying 3 over 1, right? 3 over 1 times 1 half is going to be 3 halves plus 2, right? Isn't 3 halves just like saying isn't 3 halves just like saying 1 and a half plus 2? 1 and a half plus 2 is 3 and a half. You got that? Okay. Again, if you can't do it in your head, do a side problem. I'd have no problem with that. Just get the right answer. That's all I care. Okay, 0. Let's put 0 in. 0 minus 2 is negative 2. 2 to the negative 2 is 1/4. 1/4 times 3 is 3/4. 3/4 plus 2 is 2 3/4. Okay, 3. 3 minus 2 is 1. 2 to the 1 is 2. 2 times 3 is 6. 6 plus 2 is 8. 4. 4 minus 2 is 2. 2 to the 4th, or 2 to the 2nd is 4. 4 times 3 is 12. 12 plus 2 is 14. Okay. I know I did those in my head, but that's really where we should be at, going quickly, right? All right, now we're going to plot these points at 0, 2 3/4. Okay, then we got 1, 3 and a half. Then we got 2, 5. Then we got 3, 8. And then we got 4, 14. Okay. Now if I were to graph some points like negative 1, I know that my graph would actually start looking like this. And we're going to explore why it looks like that next week, probably on Monday. Okay, but that's how the graph will look. And then again, last step, we need to identify if it's exponential growth or decay. What is it, class? Growth. So we'd say exponential growth. And that's it. Okay. And that concludes this lesson.